The next property, so that's frequency. The amplitude of a wave combined with distance determines loudness, how loud a sound sounds. So if a sound has greater amplitude, it sounds louder. Of course, if it's farther away, it'll also sound less loud. So those two together determine loudness. Intensity is how this is the physical property that this is called, and that intensity is what determines loudness. Intensity combines both amplitude and distance. The formula for intensity is power over area. And so the units of power are watts, units of area, meters squared. So power, remember, is energy per time. So we've got energy per time per area is the intensity of a sound. If we have a point source, that sound is radiating out in all directions. So whatever amount of energy that's going out is spreading out over the, if you've got a point source, it's spreading out over the surface of a sphere. So the area over which it's spread out is the surface of a sphere. The surface area of a sphere is 4 pi r squared. So if we have a point source, the intensity is power over 4 pi r squared. I'll just do a quick calculation here. A square speaker with sides 2 meters has power output of 0.15 watts. What's the intensity of the sound for a listener with an ear pressed against the speaker? Well, think about this. Okay, 2 meters square. The listener has the ear pressed right up against it. All the power is going through that 2 meters square area. So then the intensity here, power over area. Well, the power we know is 0.15 watts. The area is 2 meters. Not 2 meters, sorry. 2 times 2, 2 squared. So the area is 4 meters, and so what is that? 7.5, 3.75 watts per meter squared would be the intensity of that sound. Now, if our listener is 50 meters away, well, think about our square speaker now. It's looking more like a point source, but the sound is really only going out in one direction. It doesn't go backward. So this is kind of spreading over a hemisphere. Excuse me. And actually, it depends. If we say the speaker is rested on the ground, then the sound is spreading out more or less over a quarter sphere. So the intensity then would be 0.15 over this quarter sphere. So 4 pi r squared is a full sphere, so a quarter sphere would be pi times 50 squared. That would be the surface area we're dealing with now, and we can see that this is going to be a lot smaller than the intensity when you're up close. That's 1.91 times 10 to the minus fifth watts per meter squared. And don't worry too much. You're not going to have to worry about, you're not going to have to figure out what kind of shape you're dealing with necessarily, except, well, we will do that kind of in a lab. But you don't need to be able to figure out that that's a quarter sphere on your own. I just wanted to show you an example of how that plays out. The threshold of hearing is generally held to be about 10 to the minus 12th watts per meter squared, although we hear some frequencies better than others, which we'll talk more about on another day. On page 464, there's a table of intensities of some common sounds. You can look at that to get an idea of how intensity works. Now, our hearing, though, isn't directly, it's caused by intensity, but it's not exactly proportional to intensity. By which I mean, well, this is what it elucidates that. A sound that has 10 times the intensity actually sounds twice as loud to us, not 10 times as loud. For this reason, sounds are often measured by what's called intensity, not just intensity, but intensity level. Intensity level, which is measured in decibels, so it's often also called the decibel level. Decibel is the unit of intensity level. And there's this formula for calculating the intensity level of a sound given in intensity. I naught is the threshold of hearing, 10 to the minus 12th, so you can calculate the decibel level of sounds just by plugging into this formula. That's a log, which you have on your calculator. Yeah, and so we can calculate decibel levels based on on intensities. So for the speaker in part A, well, the intensity level beta, this is the Greek letter beta, the intensity level is going to be 10 times log of the intensity, which was 3.75 watts per meter squared, over I naught, which is 10 to the minus 12th. And we can plug that into our calculator. So that's about 126 decibels. And then part B, the other one, the speaker that far away, we got 1.91 times 10 to the minus 5th watts per meter squared. I naught is still the threshold of hearing, 10 to the minus 12th. Oops, can't make it 12. And so if we punch that in, we can get the decibel level, or the intensity level of that sound, which is about 73 decibels. Note the decibel is the log of intensity divided by intensity, which means that the decibel is a dimensionless unit, kind of like the radian. A decibel is dimensionless, but unlike the radian, you do need to say decibel as a unit after things. I don't really know why that distinction exists. So that's just an intro to sound and how sound works. We'll be talking more about sound in the days to come.